Chapter 13, problem number 18. It combines the material that we learned in Chapter 12, which has to do with capital budgeting, with the material we're learning in Chapter 13, which has to do with risk and return. In this case, you're given different possible cash flows. You're given the probability of the cash flow, so it gives you a probability distribution. And you need to multiply the probability times the cash flow to get the expected cash flow. So you take the 2,400, multiply by 0.2, and you get 480. And you do that for all four possible cash flows. You times them by the weight, and then you sum it up. So the weighted average cash flow, or expected cash flow, is $4,920 per year. You can see that in part B, you then put that into your calculator, or you can of course use Excel. And the payment would be $49.20. The interest rate would be 14%. N would be 5, and you calculate PV. See, the present value of those 5 years of cash flows discounted at 14% is $16,891. You then subtract the present value of the outflows, and you wind up with minus 3,109, and you find that it's a negative, which means you would reject the project. In the square box, you have, if you want to find IY, and you can also do this using the CF buttons, whichever you prefer, you would put in the present value of 20,000, and remember, it needs to be negative. So I'm going to add that. So you go 20,000 plus minus, which I think most, if not all of you, are comfortable with at this point. Future value is 0, PMT is 49.20, IY is an unknown, and N is 5. So in this case, you need to then go compute IY, and you get 7.32, which is less than the discount rate of 14%. That is why the net present value is negative. So in conclusion, what's the recommendation? Larry should not buy this equipment because the net present value is negative and the internal rate of return is less than the cost of capital. Cost of capital is 14%, which you learned how to do in chapter number 11. And this assumes that Larry's probability distribution is accurate. So if you had different weights for the probability distribution, you'd wind up with a different expected value. So the 49.20 would change. So you can see, and if you were to do this in industry, you would try different weights for probability to, just in case, the 40% should be 30 and the 30 should be 50 and things along that line. So you can get a net different expected cash flow, or PMT. So that's how you do problem number 18.